So, hello everyone. Have you ever wondered how two things which are way different can likely be connected? Let's say that you are studying for a test for hours and you are getting some marks. Let's say, does your marks does it depend by any chance on the amount of hours you studied or anything as such? So today we'll work into this and we'll be working into the common understanding known as correlation. Alright, in this video, we'll break down correlation, Karl-Spearman coefficient, Spearman rank correlation, and scatter diagrams to help you understand the relationship between what is positive, negative, and non-existent the correlation. Alright, so stick around and I'll show you how to interpret real life data easily. Alright, so before we start, let's take example. Alright, let's say that there are multiple variables. Okay, and in one case, when you increase one variable, the second variable also tend to increase. So that is tend to known as a positive correlation. All right, one is directly proportional to another. All right, negative correlation is when one variable increases, the other variable will decrease. And there is a value of no correlation when there is no certified value uh, that whatever x changes, y will or will not change, and there is no clear relationship. Right. So let's say we get into a real life example. Let's say you studied for an hour test for 1 hour. Let's say tomorrow is your midterm exam and you have only studied for the whole subject of economics only 1 hour. So your grades will likely be very bad. But let's say you have studied every other day economics for the whole year. Then perhaps your grade will be really good. So these two are positively correlated. The more hours you study, the more grades you will get. Let's say temperature and ice cream. All right, so these two are basically negatively correlational. Let's say if you increase the temperature, the ice cream will melt, and if you decrease the temperature, the ice cream it will remain solid, that it will be free frozen. All right, so this is the example of negative correlation. All right, and let's say that we take two random examples like shoe size of a person and IQ, intelligence of a person. So this will tend to have no correlation because it doesn't matter what your shoe size is or what your IQ is. They tend not to depend on each other. All right. Now we'll study something known as Karl Pearson correlation. All right. So Karl Pearson correlation is denoted by R, and it measures the strength and direction of a linear relationship between two variables. Let's say we have been given two variables x and y. So it basically measures the linear relationship strength between the direction, and it lies between the range of 1 to -1. Alright. If it is +1, then it is a positive perfect correlation. If it is -1, then it is a negative correlation. And if it is 0, then that means there is no correlation. Alright. So the formula for Karl Pearson coefficient of correlation is basically R is equals to summation of xy into under root of sigma of x square into sigma of y square, whereas x and y are basically x minus the mean of x and y minus the mean of y. When we'll be doing an example, then this will be more clear. All right, so as I have recalled earlier, if r is greater than 0, that means it is a positive correlation. If r is less than 0, that means it's a negative correlation. And if r is close to 0, then it is no correlation or weak correlation. So this is a data which we have taken from an example from a book. Let's say you have been given two data sets, the values of x, that is 78, 89, 97, 69, 59, 79, 68 and 61. Same goes with y. So we'll be calculating step by step the Karl-Pearson coefficient. So step 1 is what we'll do is we'll write x and y into two columns. Okay. Step 2 is we'll calculate the mean of x and y. Mean of x can be calculated as summation of x by total number of n, like total number of frequency that there is. So there are total 8 uh, data sizes, so the n will be 8. So when we calculate the mean of x, it comes out to be 75. When you calculate the mean of y, it will come to 125.5. All right. Next, what we'll do is we'll calculate small x and small y, which basically means uh, capital X minus the mean. In our case, the mean in this example, x the bar was 75, so it came out to be 3. All right. सेम 89, यहाँ पे आपका जो मीन था आपने उससे माइनस किया तो 14, देन 22, देन -6, -16, 4, -7 एंड -14. यह हुआ आपका x. सिमिलरली आप y को कैलकुलेट करोगे, देन ये दो वैल्यूज है, आप इन दोनों को मल्टीप्लाई कर दो. ऑल राइट, सो इट विल कम आउट टू बी 792. Okay, now let me remove myself. Yeah. तो सिमिलरली व्हेन आप एक्स स्क्वायर को मल्टीप्लाई करोगे तो द वैल्यू कम्स आउट टू बी 1242, एंड जब ऐसे वाई स्क्वायर को मल्टीप्लाई करके ऐड करोगे तो इट विल बी 2130. ओके, नाउ आपको फॉर्मूला क्या था? आपका फॉर्मूला था समेशन ऑफ एक्स वाई बाई अंडर रूट ऑफ समेशन ऑफ एक्स स्क्वायर इंटू समेशन ऑफ वाई स्क्वायर. आपका 3972 अंडर रूट ऑफ 1242 इंटू 130, which comes out to be 0.579, sorry 597. So see, now the correlation between these two variables x and y, it is 0.597, which particularly means कि आपका जो correlation है it is moderately positive. ठीक है, there are 3 or 4 stages of correlation. I'll explain it in detail later. So hello everyone, now we are back on to, just wait for a second. So hello everyone, now we are back to Spearman's rank correlation coefficient. Alright, so basically Spearman rank correlation coefficient measures the strength and direction of and relationship between two ranked variable, and it is basically ideal for non-linear data, in which let's say that if you increase one thing, the other data will not actually increase linearly. Alright, so the first question being, when should you use this Spearman rank correlation? So it can be used when you know that there are two variables and they have non-linear relationship. Second one, it can be used on ordinal data like ranking is in a competition. All right. In this, basically you are given two data sets, x and y. Let's say you rank them according to x and y, like all the ranks in ascending order or descending order. Then you calculate the difference in ranks and then find the Spearman correlation coefficient. Alright, now in the next slide. So, as discussed from the previous slide, Spearman rank correlation basically measures the strength of a relationship between two ranked variables. Alright, the formula can be given by 1 minus 6 sigma d square by n cube minus n. Alright, where d is the difference between the ranks and n is the number of pairs. Moving on to the next slide, here we see that let's say that there are two ranks which collide, like the difference d equals to 0. So in that particular case, we have to use this particular formula where we have to add plus 1 by 12 m cube minus m plus 1 by 12 m cube minus m, however many times m the rank has been 0. I'll show it to you in the next example. All right. So let's say that we have taken x and y as the variable here, and these are data, let's say height and rank. Okay, so what you will do is, given x, you calculate the rank of x in ascending order. Let's say 35 is rank 1, 37 is rank 2, 38 is rank 3. It's all in ascending order. Same with y. Okay, as you can see, 30 is rank 1, then 31 is rank 2, 32 is rank 3, 39 is rank 4, 46 is rank 5, 41 is rank 6. Okay, Then 42 is rank 7, 50 is rank 8, 52 is rank 9, and 55 is rank 10. After calculating the rank, you have to take the difference. So, after calculating x, y, and rank of x and y, you take the difference. 1 minus 1, it's 0. 2 minus 3, it's minus 1. 3 minus 4, it's minus 1. 4 minus 6, it's minus 2. 5 minus 5 is 0. 6 minus 2 is 4. 7 minus 8 is 1. Okay. Sorry, 7 minus 8 is minus 1. 8 minus 9 is minus 1. 9 minus 7 is 2. And 10 minus 10 is 0. Now see how many times there has been 0. Like there are 3 times. So there are 3 situations in which there are same ranks. Alright, so we'll be using the second formula. So you calculate a d square and calculate total d. Like the sum comes out to be 28. Now, as you can see, we are calculating this formula where you're calculating sigma 6 into sigma d square plus 1 by 12 m cube minus m plus 1 by 12 m cube minus 1 plus m by 12 m cube minus 1. Alright, here you will do it 3 times because m is the number of times of items with the same rank. Okay, so basically it will be 1 minus 6 into sigma d square 1 minus 12 m cube 3 times divided by n cube minus 1, and here you will be putting m equals to 3. So the Spearman coefficient will be 0.831. Okay. Now we are coming to scatter diagrams. So scatter diagrams basically show us the relationship between variables using a scatter plot. So here in this plot, the x is the independent variable, y is the dependent variable, and if the trend is upwards, wait, let me show you. So this trend basically, x-axis is the independent variable, this axis, y-axis is the dependent variable. If the trend is positive, like it is going up, okay, up, so in that particular case it is a positive trend, like it has a positive correlation. If it is going down, then it is negative correlation, and if the graph is just going randomly, then it has no correlation. All right, so the key summaries and takeaway are the correlation shows relationship between the variables. Pearson's coefficient R is for linear data and Spearman's coefficient is for ranks. Scatter plots are used to visualize correlation, and there are 3 types of correlation: positive, negative, and no correlation. Thank you so much for watching this video. Like, subscribe, and let me know your what you think about it.